Hello students, welcome back to the channel. In today's video, we will understand what a chemical equation is and what are the information and limitations of a chemical equations. So let's get started. Let's define what a chemical equation is. It is a shorthand representing the result of a chemical change. So it is a shorthand form of how a given chemical reaction is taking place. The reactants are reacting to form the final products. Okay, so we'll take the example of zinc reacting with sulfuric acid. Now remember, the reactants will always be written on the left hand side. We have the reactants and these reactants will always be written on the left hand side. And then here zinc sulfate and hydrogen is formed. The products will always be written on the right hand side. Okay, so the products are written on the right hand side, reactants are written on the left hand side. Okay, so this is a molecular equation which is showing the number of atoms of zinc reacting with sulfuric acid to form zinc sulfate and hydrogen. If I have to write the word equation, I will write zinc reacting with dilute sulfuric acid. It means I am going to write it in words. Dilute sulfuric acid forming zinc sulfate, and which gas is liberated here? Hydrogen gas. So zinc sulfate plus hydrogen. Okay, so this will be the word equation. Okay, we have the molecular equation and we have the word equation where we are showing the given reaction, that is zinc reacting with dilute sulfuric acid. Okay, now let's see what are some of the information that is being conveyed or provided by a chemical equation. So whenever we see a chemical equation, we get to know the formulae and symbols. We get to know the formula and symbol of a given chemical reaction in terms of the reactants and product. Then it also tells us the physical state of the substance. Okay, if for example we are seeing a reaction of zinc with dilute HCl and zinc is being specified, it is present in solid state, dilute HCl is present in liquid state, and the product form is zinc chloride and hydrogen gas being liberated. Now in this particular reaction, you can see the physical state of the reactant and product is mentioned. Zinc is present in solid state, dilute HCl in liquid state, and again hydrogen gas which is formed is present in the gaseous state. So these are certain things which is being told when we are seeing a given chemical equation. Next, if any special condition is required, for example in the decomposition of mercuric oxide, we write a small triangle over the arrow, that is showing that the given reaction will take place only when heat energy is supplied. So this triangle represents the heat. So when heat energy is given, then this given chemical compound breaks up to form mercury and oxygen. Okay, so these are certain special conditions. It also at times reactions like for example potassium chlorate, this given chemical reaction will take place in the presence of a catalyst. So we are writing the catalyst over the arrow. This catalyst will help in the decomposition of potassium chlorate to potassium chloride and oxygen. So that is how the given chemical reactions are being balanced. Okay, or you can say that is how the given chemical reactions are taking place when certain special conditions are present. Okay, then ratio of reactants and products. We have the example of hydrogen reacting with oxygen. Ratio meaning in which ratio hydrogen and oxygen are combining to form a molecule of water. The ratio in which the reactants are reacting is 2:1. That is the ratio in which hydrogen and oxygen are reacting to form two water molecules. So these are certain things which we get to know when we see a given chemical reaction. Now there are certain limitations also to these chemical equations, and the limitations are they may not show physical states. For example, in all the given chemical reactions, it may not be specified whether the reaction is present in the reactants are present in the solid state, liquid state or gaseous state. So that becomes a limitation. Then the conditions may not be shown, like whether the reaction is taking place in the presence of heat, catalyst, these may not be specified. So that is again a limitation. Then they do not show the concentration. That means the reactants and products, whether they are present in dilute state or in concentrated state, these conditions may not be specified. Then they do not show the nature of the chemical reaction. Nature meaning whether the given reaction is fast or it is slow, or the given chemical reaction is an explosive reaction. So these conditions may not be specified. So definitely all these become the limitations of a given chemical equation. Okay, then they do not indicate the speed of the reaction, whether the reaction was a fast reaction or it is taking days, hours, or it is an instant reaction. So these are not indicated. We cannot see the speed of the reaction when we are seeing a chemical reaction. Then heat changes in terms of whether the reaction is exo or endothermic, whether the heat energy is absorbed or heat energy is released. These may also not be specified, and they do not tell whether the reaction goes to completion. Okay, whether the reaction is complete or not. So these are certain limitations of a chemical equation. Okay, so moving on next to the concept of what a balanced equation is. What is a balanced equation? It is one in which the number of atoms of each of the element of the reactant side is equal to the number of atoms of each element of the product side. Okay, it means that the number of atoms which are present in the reactant side is equal to the number of atoms that are present in the product side. That accounts to a balanced chemical equation. If we see the reaction of zinc with sulfuric acid, these are our reactants, and once they react, what are the product that is being formed? We get zinc sulfate and hydrogen. Now let's count the number of atoms that are present in the reactant side and the number of atoms present in the product side. If we see zinc, how many atoms are there? 1 atom of zinc is there. Hydrogen, how many atoms are there? 2 atoms are there of hydrogen. Zinc, we have 1 atom, hydrogen 2 atom. Sulfur, again 1 atom is there, and oxygen, if we see, there are 4 atoms in the reactant side. Let's count the number of atoms in the product side also. Zinc here again is 1 atom, sulfur again is 1 atom, oxygen here is 4 atoms, and hydrogen is here 2 atoms. So in this case the given chemical reaction is balanced. Reason being, the number of atoms in the reactant side is equal to the number of atoms in the product side. Hence it will be called as a balanced equation. Okay, now that is what we have understood from the concept of a balanced equation. Again, if we take the example of zinc reacting with HCl. Okay, these are our reactants. Reactants are reacting, and what are the product that will be formed? We will get zinc chloride and hydrogen gas. Now let's see whether the reaction is balanced. Zinc, 1 atom is there. In the product side also, if you see, 1 atom is there of zinc. Hydrogen, how many atoms are there? 2 atoms are there, and chlorine also 2 atoms are there. And likewise in the product side also, hydrogen is 2 atom and chlorine is again 2 atom. So the given chemical reaction is a balanced equation. Okay. Next we are going to see what an unbalanced equation is. Definitely when we are saying the word unbalanced, it means that the number of atoms of each element of the reactant side will not be equal to the number of atoms that are present in the product side. Okay, if we take the same example of zinc reacting with HCl, we are going to get zinc chloride and hydrogen gas is liberated. Now in this case, if we see zinc, it is balanced both the sides, but hydrogen and chlorine is not balanced, because here if you see in the product side, 2 hydrogen and 2 chlorine atoms are there. So an unbalanced equation is one in which the number of atoms of the element of the reactant side is not equal to the number of atoms of the element that are present in the product side. Okay, next the question is why we need to have an equation always balanced. What is the need for the given chemical equation to be balanced? It is in accordance to the law of conservation of matter, that matter is neither created nor destroyed, hence during a chemical change. Hence, in accordance to this law, the given chemical equation must be balanced. That is, law of conservation of matter is the reason why a given chemical equation needs to be balanced. Okay. Now, to balance a few chemical equations, we will take few simple examples so that you understand how we balance a given chemical reaction. We are taking the example of magnesium reacting with oxygen forming magnesium oxide. In this case, if you see, magnesium, one atom is there, we need to balance the oxygen. So, in order to balance the oxygen atom, we are going to place 2 in front of magnesium oxide. So, when 2 is being placed, magnesium also needs to be balanced here. So, magnesium is balanced and oxygen is also balanced. So, both the sides you have to see that the reactants and the products are getting balanced. Okay, next example we are going to see potassium chlorate, KClO3. This undergoes decomposition to form potassium chloride and oxygen gas is liberated. Now let's see how to balance this chemical reaction. Potassium is 1, chlorine is 1, both the sides, but oxygen is not balanced. In the reactant side it is 3 and the product side it is 2. So simply we are going to place 2 in front of potassium chlorate. Now potassium here again in the product side also will become 2. Chlorine is 2, here also chlorine is 2. Oxygen is 6 here, 3 2s are 6. So here we are going to place 3 in order to balance our oxygen. So here also oxygen becomes 6. So each and every element you have to see when you are balancing a given chemical equation. Next, if we take mercuric oxide forming mercury and oxygen. Now in this case also we need to balance the oxygen. It is very simple. You will place 2 in front of mercuric oxide. Here also mercury you have to change it to 2 and the oxygen is getting balanced. So remember children, whenever you are balancing, you will always place the value in front of the given chemical compound. You will never insert, like if I am talking about mercuric oxide, you will not write 2 after oxygen. That will be a wrong way of balancing, because you will be changing the chemical formula of mercuric oxide. So every time you have to add the value in front of the given chemical compound. Okay, so I hope we discussed only 3 of the examples. In the next video, we will be taking more of balancing of chemical equations. Thank you, students.